we have this problem. It's an integration. And here we can see that there's only one parenthesis. So, and we see there's a cube here. So we know we have to use this formula, that's the binomial theorem. And we have to expand it, and then we have to get the antiderivative of each term. First, we have to cube the a, which is 27x to the 6th power. Then minus 3 times a squared b, which gives us 27x to the 9/2. Then we have to do 3 times a b squared, which gives us 9x cubed, and finally b cubed will give us negative x squared x.
Okay, first of all, to facilitate our operation, we're gonna make this x negative x to the 3/2, because this is 1, this is a whole, this is a 1/2. 1 plus 1/2 is gonna be 3/2. Okay. Now we're using this formula to integrate this one here. So first of all, we're gonna have 27x to the 7th over 7. Then after this, we're gonna add this one. It's gonna be 11/2. Then we're gonna flip it over to 11ths times 27. Then we're gonna have 9x4 to the 4th, and then we're gonna have this plus 1 plus 2 is gonna be x to the 5th 2's, and then this number we're gonna flip it over, so it's gonna be 2/5. This is this. But the proper way to write an integration is like this. This is our answer. Plus C. The C and the start, it's really important. My name is Noé Jaspiado, and this is my friend Guardado, and
this is how you integrate this function.
Here we have to choose a variable that we call u. So to check which one is u and to see if the problem is available for substitution, we have to check that we have difference of exponents. Here we have 1/2, and here we have negative 1/2. That's one number of difference, so it's okay. We have 2 and we have a 0 number here, so it's okay. So our u is going to be this variable. So now that we have u, we pick du is gonna be 1, negative 1 over 2x to the 1/2, and our dx is going to be du over 1 over 2x to the 1/2.
Now that we have these components, we now have to substitute. So it's 6 over square root of x u of 7 times du over negative 1/2 x squared. We now here can cancel this over this, and we divide this over this, so it's 6 divided by negative 1/2, which equals negative 12. And then we have to substitute negative 12. We have to integrate, I'm sorry. We add a 1 here, so it's u 8 over 8. And substitute the equation, substitute the u, which is negative 12 over 8 2 minus 1/2 plus c, and simplify. And if you point the calculator, 12 over 8, it's 3 over 2, so it's negative 3 over 2. Substitute the u, which is 2 minus square root of x to the 8 plus c, and don't forget to put the integration here,
dx.
and
f of x dx.
So question number 2 is asking us to find the period of a pendulum with this given formula. It tells us that the length is in feet, the g represents acceleration, which due to gravity, which is 9.81, and t is time in seconds. They tell us that the x1 is 4, and it changes in a 0.5%, which will give us that x2 is 4.02. Number A is asking us to find the change in the period of the pendulum if the original length is 4 feet. So we're gonna use this formula and putting all the variables into the f of x2. x2 is 4.02 as we have in here, and x1 will be 4. This answer, this change in period will give us 0.01002. In number B, they're asking us to find the percentage of the change, so we only have to use this formula. So the answer we got in number A, which is 0.01002, divided by this answer, this only answer, which is f of x1 times 100. The answer will be 0.2497%. In number C, they're asking us to find the approximate percentage change in the period. If this was our original formula, this is the same as having this. So using chain rule, we're gonna have the derivative, which will be this one. dl is x2 minus x1, which is 0.02. So we only put the variables, the values of each variable inside the formula, which will give us pi over square root of 9.81, which is g gravity, and times square root of length, which is 4. All of these times dl, which dl is 0.02. The answer, the approximate change in period, will be 0.0100. We can see in here that this answer is a little bit less specific than number A, which is the change in period, since this is an approximation. In number D, we're gonna find the approximate error in 1 day, and 1 day is the same as 86,400 seconds, and so we only have to multiply this. We used the seconds in 1 day because they told us that time, we have it here, is in seconds. So we put the seconds in 1 day multiplied by the approximate change in period, which is 0.0100, and the answer will be 864. Explanation in number E is that using the differential, we could see the change in period of the pendulum within time, which is 1 day, or 86,400 seconds. Thank you.